Here we go. 2.2. Why is global population increasing? Components of population growth. Geographers measure population change in a country or the world as a whole by using three measures. And these are abbreviations you need to know. Crude birth rate, crude death rate, and natural increase rate. The crude birth rate, or CBR, is the total number of live births in a year for every 1,000 people alive in a society. The crude death rate is the total number of deaths in a year for every 1,000 people alive in a society. And the natural increase rate is the percentage by which a population grows in a year. And it's a simple mathematical formula. If you look at it, you take the CBR, the crude birth rate, minus the crude death rate. That gives you the natural increase rate in a percentage. Always remember the natural increase rate, or NIR, is a percentage, while CBR and CDR are expressed in numbers as N per 1,000. Let's take a look at this population timeline here. A couple key concepts that we're going to go over here. First of all, you'll see the NIR, natural increase rate, is the percentage. For most of human history, 400,000 BC to 8,000 BC, you can see the human population relatively is unchanged. Annual and natural increase rate is very, very low. And the amount of time it took for the population to double, 59,000 years. Okay, 59,000 years. Then human population starts to pick up between 8,000 BC and 1 AD. It goes to 0.05. It took about 1,345 years for the population to double. Then, as you notice, these time spans get shorter into 50-year increments. 1750 to 1800, annual NIR is to 0.43. That means that it takes the population 163 years to double. 18 to 1850, 0.51. 1850 to 1900, 0.54. Then you see here from 1900 to 1950, the NIR is 0.81, which means the doubling time, and that is for the total population of the Earth, to double is now at 85 years. Then we see a dramatic, and I do mean dramatic, increase between 1950 and 2000. The natural increase rate is 1.75. That means it takes 40 years at this point, at this annual percentage rate, for the population of the Earth to double. Okay, the current population as of 2012, as you can see, is 7,037,000,000. And you can see in this bar graph here that the jump in the population of the Earth in the last 50 years is staggering. Okay, and it's going to continue to go that way because of doubling time. Natural increase. About 82 million people are added to the population of the world annually. The rate of natural increase affects the doubling time, which we've already mentioned, the number of years needed to double the population. But that is assuming a constant rate of natural increase. If I go back, you'll see that the natural increase rate is not always the same. That could be because of various factors. That could be because of war, famine, disease. Who knows? Maybe we'll get hit with some zombie virus that wipes out most of the population of the Earth, a thermonuclear war, and that would definitely affect doubling time. 21st century rate is 1.2%. That means doubling time is every 54 years. Now, if you continued at 1.2%, global population in 2100 by the end of the century would reach 24 billion people. In 1963, that 21st century rate of 1.2 had went up to 2.2, which meant that the population would double every 35 years. So, global population in 2010 would have been 10 billion instead of nearly 7 billion. As you can see, there are fluctuations in the natural increase rate, but overall, the population of the Earth is going to grow exponentially. The doubling time is going to become shorter and shorter just because of the sheer numbers that we're dealing with now. More than 95% of all natural increase is clustered in developing countries. Now, this is a huge problem. That means that the population growth around the world is in developing countries that are not economically, socially, medically advanced enough to deal with some of these population problems and the issues that come along with them. If you look here at this map, you'll see the world natural increase rate by year, percentages, and you'll see that in South Asia, the Middle East, Sub-Saharan Africa, some of the poorest places on the globe, they also have the highest natural increase rates. Their populations are growing way, way faster than in some of the more developed countries in other parts of the world. Components of population growth include fertility. The TFR stands for total fertility rate. It is a basic measure of how we measure the number of births in a society, and it's defined as the average number of children a woman will have throughout her childbearing years. The average woman's childbearing years range from 15 to 49. But what you're going to see as we study this a little bit more closely is that differs by region. In places like Sub-Saharan Africa, the TFR exceeds 5, while 2 or less in all European countries. So depending on a various number of factors, your women in lesser developed countries, their childbearing years usually start younger. Women in more developed countries, their childbearing years can be delayed until later in life. Also, the number of children that people have. I mean, for the world, 2.5, that's the average number of children a woman will have, 2.5. That's right, 0.5 kids. Interesting. But in Sub-Saharan Africa and lesser developed countries, that number goes through the roof. Mortality. The infant mortality rate, or IMR, measure used by geographers to better understand death rates in a society. It's defined as the annual number of deaths of infants under 1 year of age compared to the total live births. So these are the number of kids who never make it past their first birthday. It's usually expressed per 1,000 births rather than a percentage. The infant mortality rate is 5 in developed countries. That's right. The average for developed countries, including the United States, is around 5 kids per 1,000. And 80 in Sub-Saharan Africa and other lesser developed nations. Here you see in purple the crude birth rate per 1,000. Once again, the highest birth rates, Sub-Saharan Africa, East Asia, the Middle East, Southeast Asia. Your more developed countries like Europe are actually in the negative in some, and we'll get into that in a little bit as well. Children per childbearing years per women, as we see above 4 as in Sub-Saharan Africa, usually in the 5 or higher. South Asia, the Middle East, Southeast Asia, all of these women are having more kids, a lot more kids than they are, say, in Europe, the United States, or Canada. Summary of spatial patterns. We're going to compare throughout this course constantly developed countries with developing countries. A lot of times you'll hear the abbreviation, and this is something you need to remember from here on. MDC, more developed country. LDC, lesser developed country. In MDCs, they have lower rates of natural increase, lower crude birth rates, lower total fertility rates, and lower infant mortality rates. And we'll debate the reasons why. Why in more developed countries are these things lower? In developing countries, in LDCs, they have higher rates of natural increase, crude birth, total fertility, and infant mortality. And you need to be able to easily compare these two and know the answers for this. And we'll discuss these a little bit more in class. Crude death rate per 1,000, no surprise. Sub-Saharan Africa with the most, South Asia. And then you'll see quite a bit actually here in Eastern Europe. And the reasons for that we'll get into a little bit later. Population structure. Fertility and mortality vary not only spatially, but also temporarily within a country. So you might have some years like the United States, the baby boom generation after World War II. Many soldiers came home after World War II. Economic growth was very good, good times, big baby boom, okay, but that was only for a short period of time. A special bar graph known as a population pyramid can visually display a country's distinctive population structure. There's an x-axis and a y-axis. The x is always the percent of males displayed to the left. and females are always displayed to the right. So men on the left, and as my wife likes to say, women are always right. On the y-axis, you have age cohorts typically grouped in 5-year intervals. The youngest at the bottom, oldest at the top. So once again, on a population pyramid, you have men on the left, women on the right, young at the bottom, oldest on top. Here you see a couple population pyramids. This is overall for the United States. Lawrence, Kansas, Naples, Florida, Laredo, Texas. Now, remember, men on the left, women on the right, young at the bottom, old at the top. And you can tell a lot about a population just based on the population pyramid. Population structure, there's something called the dependency ratio. This is defined as the number of people who are too young or too old to work compared to other people in their productive years. We said that a woman in her childbearing years is between 15 and 49. We're going to say that people in the dependency ratio that are under 14 and over 65 are considered dependents. That means they can't take care of themselves for the most part. So under 14, over 65. Larger dependency ratios imply greater financial burden on the working class. 85% in sub-Saharan Africa, while only 47% in Europe. One of the big challenges we face in this country is that as our population ages, the dependency ratio is going to increase here in the United States with that baby boomer generation that I mentioned just a minute ago starting to enter retirement. The sex ratio is defined as the number of males per 100 females in the population. Developed countries or MDCs have more females than males because they tend to live 7 years longer. That's right, women usually in MDCs outlive men by 7 years. My grandfather said that's because women suck the life out of men, but that's just his opinion. Take a look here at the sex ratio. This is worldwide. The countries in blue have more men than women, tan about the same, and in purple, more women than men.